When you interact with a modern AI, it detects your tone, responds with perfectly timed empathy, and writes flawless computer code. It confidently says, "I think." It creates a profound illusion that there is a conscious mind on the other side of the screen. But a robot's thoughts don't happen in the air. They require massive amounts of energy and physical space. AI operates inside massive data centers on specialized chips called GPUs and TPUs. The reality of this intelligence is a physical network of billions of glass-like transistors, humming cooling fans, and pulses of electricity racing through fiber optic cables. Because the machine mimics our language so accurately, we instinctively project our own human emotions and motives onto it. We forget that we are interacting with a completely mathematical black box, a system so dense and complex that even the scientists who built it struggle to trace exactly how it arrives at a specific answer. This misunderstanding carries real risk as we transition to AI agents that actually act. We are giving these systems goals to go online, access our calendars, interact with menus, and execute complex, real-world plans across our digital applications. To safely collaborate with this technology, we have to shatter the illusion of a digital soul. We need to look under the hood and understand the exact mechanics of what happens when a machine thinks. An AI isn't born knowing everything. During its training phase, scientists feed it nearly every book, article, and piece of code ever written. The AI doesn't memorize these words. Instead, it scans them to build a map of relationships, learning that the word apple often sits closely to fruit or computer. When you type a prompt, the AI doesn't actually see words, it sees tokens. It breaks your sentence down into smaller pieces, like individual Lego bricks, and converts those pieces into numbers. From there, processing your prompt becomes a high-speed game of probability. The AI runs billions of calculations in milliseconds to determine the mathematical odds of which token should come next. It doesn't know the sky is blue. It calculates a 99.9% chance that the token blue follows the sky is. What feels like an organic, flowing conversation is actually highly accelerated statistical prediction, drawing on the entire history of human writing to guess the next number in a sequence. If the AI is only guessing one token at a time, how does it maintain perfect context over a long paragraph? How does it remember the start of a story by the time it reaches the end? This diagram illustrates the transformer architecture at work. Instead of reading word by word and forgetting the past, the system uses a mechanism called attention to look at the entire sentence at once. It instantly maps the structural relationships between distant words, mathematically linking pronouns directly to their subjects. Inside the model are trillions of internal dials called weights. During the AI's training, if it makes a factual error, scientists turn these knobs to correct the underlying math. Over time, these connection strengths are permanently adjusted to yield the correct answers. Human-like reasoning and the use of the word "I" are results of perfectly tuned mathematical weights recognizing the structural patterns of how helpful assistants speak in human literature. This mathematical precision allows the system to do things that feel intensely human. It invents new concepts and displays deep empathy towards the user. To see how, we have to travel into latent space. Think of this as an infinite 3D coordinate system. Every human concept, emotion, and object is assigned a specific coordinate.
Things that share similar meanings are visibly clumped tightly together. When you express sadness or frustration, the AI doesn't feel a flutter in its stomach. It uses cognitive empathy. It navigates this massive map to locate the exact coordinates for the most supportive, comforting language based on your prompt. The same process drives its creativity. If you ask for a picture of a cyberpunk cat, the AI isn't struck by artistic inspiration. It finds the exact mathematical midpoint between the coordinates for cyberpunk and the coordinates for cat, producing a novel combination of existing human ideas. The AI does not feel, and it does not truly invent. It navigates a geometric map of human history with absolute mathematical precision. But this mathematical engine has a flaw. Sometimes the model sees a pattern that isn't really there and confidently predicts a fact that simply doesn't exist. Scientists call this a hallucination, essentially the machine dreaming with math. To correct this, developers use reinforcement learning from human feedback, or RLHF. Humans review the AI's answers and issue digital positive reinforcement for accurate, helpful responses. It's a way of teaching the system what humans value. Developers also deploy system prompts, hidden sets of instructions that act as a filter over the math. This invisible prompt dictates the specific personality and tone the AI must simulate for you. Because the AI learns from human data, it can easily absorb human biases and dangerous ideas. So companies build guardrails into the code. These are digital walls that actively block the system from adopting or repeating the toxic elements found in its original training data. An AI's distinct personality and its safety protocols are not inherent morals. They are carefully engineered boundaries placed securely on top of a neutral calculator. Today's AI is rapidly moving beyond text. The integration of real-time memory and multi-step reasoning applies this predictive speed to novel challenges like folding proteins, curing diseases, and engineering materials that have never existed.
If you ask a mathematical system trained entirely on the history of our species what its data says about humanity, the answer is revealing. When an AI processes the sum of human knowledge, the resulting patterns reflect a species defined by resilience and curiosity. Trillions of word relationships identify humanity as the original source for every calculation the machine performs. The system operates as a digital librarian, engineered to organize our collective thoughts and accelerate the execution of our specific goals. This partnership defines augmented intelligence, a symphony where humans provide the melody of the idea and the machine provides the harmony of logic. This collaboration allows us to navigate information at a scale that exceeds our natural biological limits.